Okay, so this TEST-12J, class 10 electricity, okay? These are the 3 questions we'll do, after which you take your test. So you go to page number 233 of your textbook. Okay, this is on electricity 16. I'll read the question for us. How many 176 ohm resistors in parallel are required to carry 5 ampere current on a 220 volt line? So how many resistors are we going to require? So that's what we're going to have to find out. So let us assume let n be the numbers of 176 ohm resistors, as the question puts it that way, in parallel. So specifically condition is it must be in parallel. So how many of 176 ohm resistor type, how many numbers, if you connect in parallel, will you get that condition? So that's what the question is saying, be the numbers of 176 ohm resistors in parallel that will be required for the given condition. So for this, let us assume, since they are in parallel, let Rp be the total resistance, value of the total resistance. So since clearly they are in parallel, so formula will be that of the parallel formula, reciprocal of total. 1 by Rp will be equal to, how many? So suppose they are 1 by 176 plus 1 by 176. So how many we don't know. So the unknown is now n. So if you add this n times, then it's the same as n multiplied to reciprocal of the 1 resistor, right? It's just like 1 by x plus 1 by x plus 1 by x, then 3 of them, so 3 into. So since there are n numbers, so n is multiplied to reciprocal of the first, reciprocal of one value, right? Reciprocal of the one value. That is the formula. So having done that, we're going to have here, as we cross multiply 1 into n, and then n into this cross multiply Rp up and down, Rp will be equal to, and 1 into 176 is 176 ohms. So and then this n, if you cross multiply, sorry, here, n into this is n into Rp. So that is what we're going to get. So next step, slight arrangement, and Rp will be equal to 176 divided by this n will come down this much ohms. Let's just keep this one as 1. Okay. Now as we read the question further, we see current is 5 ampere and voltage is 220 volts. So I is the current, 5 ampere, as given in the question. And volt means potential difference, so V equal to 220 volt. This is the potential difference. So I, V and Rp is there, means only one formula we can use with this, using Ohm's law. Ohm's law, we know V is equal to I into R. But in our case, the R total is Rp. So this is the Ohm's law equation, right? So if we were to put this one, Rp don't move, then if we shift this I, it will come to denominator, so V by I. So V is 220 volt, and I we just wrote now 5 ampere. This is Rp, and Rp is, here, see here, 176 divided by n ohms, this much. So right here, since using equation number 1, and knowing that V is 220 volts and I is 5 ampere. So here you can see I 5 ampere, V 220 volt, and then Rp in equation 1, 176 by n. Getting right. So we know now that here 220 divided by 5 volt by ampere is, we know, ohms, so we can replace that. 176 divided by n ohms. So these ohms here, right side and left side, will cancel, because if you shift this, it will go to denominator and cancel this one. So we can now cancel 5 4s are 20, 2 in hand 20, 5 4s are 20. So one more step to go, I think. And write the CH-12. So here you write the direct plus here, cross multiply down and up, so n into 44 is 44n, then put equal sign, and 1 is left, so 1 into 176 is 176, right? Okay, one more step and I think you'll get a number. So n equal to 176 into, means this 44 will come to denominator, so 11 will go, I think. 11 4s are 44, 11 1s are 11, 6 remains, so combined with the 6, 66, 6 are 66, so 4 1s are 4, 4 4s are 16, so 4 numbers. So the answer is 4 numbers, right? So that is your first question, number 16. Now let us go to 17. In this class we'll do 16 and 17, and in the next class we'll complete with 18. Okay, so let us go now and do 17. Okay, so here 17 is, let me read the question. Show how you would connect 3 resistors. You're given 3 resistors, each of resistance 6 ohms, so that the combination has a resistance of 1, 9 ohms, and second one 4 ohms. So let us start with the 1. The total should be 9 ohms. So for this, let us say, let 3 resistors are given. So let the first two, let the first two 6 ohm resistors be connected, okay, connected in parallel. So let RP be the total here, RP1 if you want, total resistance. Since they are clearly in parallel, so formula will be reciprocal of total 1 by RP1 will be the reciprocal of the first 2 resistors. The first one 1 by 6 ohm plus 1 by 6 ohm. So, or you can just put RP, that's fine, I think. RP1 also fine. Now that implies 1 by RP will be LCM here 6 and 6 is 6 ohms. Then denominator 6 1s are 6, 1 1s are 1. Similarly 1. So 1 by RP will be equal to 2. 1 plus 1 is 2 by 6 ohms. So 2 1s are 2, 2 3s are 6. So if you cross multiply RP into 1 is RP, and 3 1s are and 3 ohms here. So let us continue. So let this RP equal to 3 ohm be now connected, be further, if you want to add the word further, connected to the third. First 2 are taken, so 3 are there, so 1 piece is left, so third 6 ohm resistor. Now let R, as since our resistor in series, okay, in this time now in series, so these two, they combine in total. Their total now connected to the third one, the third 6 ohm resistor in series. So if it is series, let RS be their total resistance value, which we have to calculate. Okay, let RS, or you can simply say R be the total resistance. So since this RP and this 6 are in series, the formula for total formula will be first one RP plus second one. Right, so this one RP here is 3 ohms, so you can replace it by 3 ohms plus 6 ohms will give you equal to 9 ohms. So we're getting the required value. How to get the total 9 ohm? First two 6 ohm resistor connected in parallel, their total will come 3 ohms. That total connected to the third 6 ohm resistor in series, and you'll exactly get 9 ohms. So we can say here, so to get, according to the question, so that the combination has a, okay, therefore the combination will has a resistance. Okay, same language, has a resistance of 9 ohms if the first two 6 ohm resistors are connected in parallel. Okay, parallel, and this in turn is connected. This in turn is connected to the third 6 ohm resistor. Finally, 6 ohm resistor. Finally, 6 ohm resistor in series. I hope you got it. I get a total of 9 ohm if the first two 6 resistors are connected first in parallel, and this in turn is connected to the third 6 ohm resistor in series. Like below, you can write there, and so we can make it clear, like below. Means we're going to draw a figure. So let us do that. What this statement means is that when you connect the first 6 ohm resistors to the second 6 ohm resistor in parallel, then this parallel, first two connected in parallel, is connected to the third 6 ohm resistor in series, means after the ending like this, then you're going to get plus minus battery, and switch on means current will flow like this. Then first two in parallel, then connected, this combination of parallel connected in series to the third, then you're getting total 9. That's what we mean. So after this statement, we draw this diagram. Okay, I hope you got it. Write it down. Okay, so let's write it down. This one, right, and draw this one. Okay. Okay, 17 subheading 2 now. First subheading is 9 ohms, total should be 9 ohms. Second subheading is total should be, look at your text, 4 ohms. So how do you get a total of 4 ohms with 3 6 ohm resistor like this given? 1, 2, 6 ohm, 6 ohm, 3 are given. What we need, the question means to say, how would you connect these 3 in what manner so their total will come out 4? So here let the first two 6 ohm resistors be connected in series. So let us first do it in series. Let RS series, so RS be their total resistance. That means the total resistance of the first two 6 ohm resistors when they are in series. Okay, RS be their total. So since they are clearly in series, so the formal total RS will be first one plus second one, which is simply equal to 12 ohms. 6 plus 6, 12. So let this RS that you got just now, 12 ohm, be in turn connected to the third. So these two are first connected in series, and after the series the total is 12. That 12 combination of these two connected to the third, this one, third in parallel. Then we're going to get the required value of 4. Okay, so let us write here, let R be their total resistance. Total resistance of RS equal to 12, and then the 6 to the third, okay, to the third 6 ohm resistor, 6 ohm resistor in parallel. So this 12 is connected to the third, this one in parallel. So then the total of RS and 6 is as R, put as R. Since they're in parallel, therefore the formula will follow 1 by R. Reciprocal of total is 1 by RS, the first one, and the second one, which is the third 6 ohm resistor, plus 1 by 6 ohms. Right, you're getting right. So that gives you 1 by R equal to 1 by RS. Just now we got 12 ohms value. So replace it by 12 ohms plus 1 by 6 ohms. Hope you're getting right. So it gives you 1 by R equal to 12, and 6 LCM is 12 ohms. 12 ones are 12, 1 ones are 1. 6, how much is 12? That's right, 6 twos are 12, so 2 ones are 2. So that gives us 1 by R equal to 1 plus 2 is 3 divided by 12 ohms. Right. And easily cancel these 3 ones are 3, 3 fours are 12. So this here, R into 1 cross multiply, R, 4 ones are 4, ohm also will come out. Total is exactly coming the required 4. When we connect the first two in parallel and first two in series, and the combination which comes out 12 is connected to the third 6 ohm resistor in parallel. So when you connect these two in parallel, after which connect these two combination to the third in parallel, first two in series, and then connect the combination to the third in parallel, then we're getting 4 ohms. So we can write the answer now. Therefore, you see, after this you can write down, therefore, you can write it short now. To get this 4 ohm, we have to connect the first two 6 ohm resistors in series, which in turn should be connected to the third 6 ohm resistor in parallel. Only then S below, we'll show a diagram also, only then we'll get a total of 4 ohms. So the first two here should be connected, we found out by calculation. When 3 6 ohm resistors are given, the first two should be connected in series first. That combination should be connected to the third one in parallel. Then the total will come out 4, as we can see by calculation. So how do you show this? First one 6 series, then this one is connected. First one, second 6 ohm. These two combination connected to the third in parallel means above and below. And I have to show the battery here, switch, long, short, okay. Plus, minus is the short, dot means current flow like this. So these two in series, first two, and the first two in series is connected to parallel with the third, then you're getting total 4 ohms. I hope that's clear, right? We'll do the question 18 in the next class, after which you can give the test, okay?